that electric field. Alright, let's do another one. If the magnitude of electric field in the air is as great as 3 times 10 to the 6 Newton per Coulomb, the air becomes ionized and it begins to conduct electricity. Now, how many of you have experienced when you go and try to open the car, you get a shock? Now, why is it happen? Why does it happen? You see, during the dry season, when your hands rub against your clothes, especially if it is polyester, you accumulate a large amount of charge on your body. And when you try to open the car, these charges will jump from your body to the car. In other words, the air becomes conducting. If I place a large amount of charge on this metal sphere, soon it will start sparking. Now, what is the process of sparking? It will make air around it a conductor. You see, the air becomes conducting and electric charges will begin to move through that air. And how much electric charge, or what should be the electric field, what is the maximum electric field in order for that to happen? If I can place enough charge on this so that the electric field on the surface of this conductor is as great as 3 times 10 to the 6 Newton per Coulomb, then there will be dielectric breakdown. Now, what is the meaning of dielectric breakdown? You see, a dielectric is an insulator, something that does not allow electric charges to move through. What is the meaning of dielectric breakdown? That property is broken down. Broken down under what conditions? When the electric field is very high. So a very high electric field can break down the insulating property of air and make the air conducting. And that happens at this very high voltage. So that must be clear as we do this problem. If the magnitude of the electric field is as great as 3 times 10 to the 6 Newton per Coulomb, the air becomes ionized. What's the meaning of ionization? Air become ionized means the atoms of air gets ripped apart. You know, an atom as a whole is neutral. If it gets ripped apart, then it produces a positive part and a negative part. They are called ions. And they are free charges. Now, when air contains free electric charges, it becomes a conductor. You see, it can now allow electric charges to flow through. Now, this high electric field will produce ionization, which results in the dielectric breakdown. Okay, a charge of 18 microcoulomb is to be placed on a conducting sphere. What is the minimum radius of a sphere that can hold this charge without producing dielectric breakdown? Now tell me, what is the electric field on the surface of a charged sphere? We have talked about it several times. What is the electric field on the surface of a charged sphere? It will be kq over r squared. So Q, the amount of charge on the sphere, is 18 times 10 to the negative 6, 18 microcoulomb, is these many coulombs. We need to find the value of the radius r of that sphere, which will produce a maximum electric field. In other words, the electric field will not exceed this value. If the electric field exceeds this value, it will create dielectric breakdown. Now, in order to prevent the dielectric breakdown, we need to keep the electric field within this range. So we will go up to this value. So we say electric field is 3 times 10 to the 6 Newton per Coulomb. If r is the radius of the sphere, then sigma equal to Q over 4 pi r squared. If Q is the total charge on the sphere, then the area of the sphere will be 4 pi r squared. The total charge divided by the total area will be the surface charge density. Now, Q is 18 times 10 to the negative 6 divided by 4 pi r squared, and that will be the surface charge density. And what is the expression for electric field just outside a conductor? Well, I simplified this and I wrote it as 1.43 times 10 to the 6 divided by r squared. In fact, 18 divided by 4 pi, is that correct? Take a look. So sigma equal to 1.43 times 10 to the negative 6 over r squared, where this 1.43 is 18 divided by 4 pi. Now, the electric field En just outside the conducting sphere is sigma over epsilon naught, which is actually kq over r squared. It will give you the same result. So E equal to sigma over epsilon naught, and sigma is this value. So if you now replace sigma by this value and use epsilon naught is 8.85 times 10 to the negative 12, this will be the electric field. And what is the maximum possible value of this? 3 times 10 to the 6. This quantity cannot be greater than 3 times 10 to the 6 Newton per coulomb. So we take this quantity and set it equal to 3 times 10 to the 6 and then solve for r. That's a very simple equation. We can solve r squared equal to this quantity divided by this number times this number, and that will be 0.055, or r equal to 0.235 meter. Okay, that's been a good problem. Well,